In today's video, we're taking a look at an all new camera from Foxeer. Now this is called the Foxeer Cat 2 Micro Super Starlight. However, this comes in two different flavors. We have a micro and a nano, and currently we're going to be taking a look at the micro. Now before continuing on, there are timestamps down below and also shown in the video progress bar, so you can go ahead and skip to whatever part of the video you'd like. PCBWay is one of the leading PCB manufacturers out there, and it is the manufacturer I use for my products. Now if you're either a hobbyist and or looking to create a final product, PCBWay is going to be a really great choice with their 24-hour and also assembly services. So go ahead and check the links down below. So let's talk about this camera. Now this thing is going for roughly $50, and it's for a couple reasons. They're stating it's super low latency, which we're going to test, and that it could run in very low light conditions, which is really great, especially for those summer nights. Now, they also encouraged me to really go and fly this at night and just to get my overall impressions and to show you guys. However, currently I'm unable to due to the lockdown, but eventually I will be. So let's take a quick look at some of the things they do provide you with. Obviously, you get the lens cover, you get the camera itself. This is a pretty fat lens here. I mean, it's really big lens. And what's really nice about these is they run 16:9 and 4:3, so you can choose whatever you want to fly, and also PAL and NTSC, so you don't have to buy it and just, you know, get stuck with PAL camera or NTSC camera, because lately we've had a bunch of new hardware that's not really, you know, compatible with NTSC or PAL, and it could create a lot of problems, especially with the goggles right now. So we also get this silicone wire, which is pre-made basically for a TBS, I think, Unify here. However, what you tend to do is just end up cutting it anyway. So that's really nice that it has another use case if you did have the TBS Unify, where you can just plug this right in, I guess. But you're more than likely you're going to have to cut this wire up around this area right here. And I'll show you how to do that in a bit here. So if we take a look at the back side here, what's really nice is they also do provide us with a V-Sense. Now the V-Sense is basically a multimeter, and you would connect it on the positive line of your battery, where your battery is connecting into your flight controller or ESC. And it'll give you the battery voltage if you didn't have an on-screen display. Now the OSD here, the second one over, is basically to control the settings of the camera, which is really great. So if you had a flight controller that can do that, you can easily route that there. Video ground VCC. Now why is it VCC and not 5 volts? Well, because it takes 4.6 volts all the way up to 24 volts. However, and again, I always recommend never setting these up on battery voltage unless you really have to, because the inbuilt filtration on these cameras isn't that great, and you could get lines in your video feeds. So I'd highly recommend to always power off your cameras off a stable voltage regulator, whether it's a 5 volt, whether a 9 volt, 12 volt, whatever is within the spec of the camera itself here. So they also do provide us with the OSD remote in order for us to change our settings, and a bunch of screws and spacers if you needed those. So let's go ahead and jump into the latency testing now. Alright guys, so the testing results are in, and before we get into them, I want to explain to you how this oscilloscope reading works here and how is my testing methodology. So on the oscilloscope, we listen into two main wires, one being the voltage line for an LED, so I'll explain why in a bit, and the other line is going to be the yellow wire from your FPV camera, which is your video feed. So there's a video feed from the camera, and here's an LED. Now, what the hell does an LED have to do with anything? Well, what I do is I put the camera in a box, which is basically just pitch black, and I put an LED in there. So while the LED is in there, it's basically off. And once it turns on, we listen to both when it turned on and also how long it took for the video feed to actually register that there is light inside the box. Here on the bottom is again the LED. So this is 0 volts. So that means the LED is off currently. So this is off. And this is the point where the LED turned on. And here we can say it turned into 5 volts, which is basically on. And what we can do at the same time is monitor the same line, the video feed line here. And we can see from the point where the LED turned on to where it actually registered something. So we can see that the video feed registered something right in this area. And we take these two cursors right here, and it'll calculate the difference for us. And that's 1.96 milliseconds. That is insane. This camera is crazy. Low light performance and just insane latency. Now, there's also something pretty unique about this. Some other cameras, they fluctuate in latency. So they can be like 5 to 7 milliseconds or 10 to 15 milliseconds. This one is stable and static, 1.96 to 1.98 milliseconds. So even less than 2 milliseconds, which is just crazy here. So it's just amazing. So we can see here 1.9 milliseconds on this test, 1.98 milliseconds, 1.96 milliseconds, which is really good here. However, Now when the LED starts turning off, so basically you're in a well lit room and it goes to darkness.
Darkness. Because of my complexion, used to call me darkness.
Then on every single FPV camera, that's where you see the latency increase. And this is why I do 2 tests. So this one's a pretty unique case. So let's go ahead and jump into the LED turning off. So from on to off and see how it affects the latency. All right, so now taking a look at the LED turning off's latency. So here's the LED. As we can tell, it's high this time. So it is 5 volts. So we'll say LED. And we can see this is the point where it turned off. So we'll say 0 volts. So off, basically. So here what we see is we see a really long descent on the FPV camera's part. But if you take a closer look, so here's the LED, it turned off, and as you can tell, everything is still the same. Right about here, there's a little pivot, if you take a closer look, right here, which is the point where it actually registered the LED turned off. However, we don't see immediately go down to 0 is because of, you have the wide dynamic range, you have all these things working in the background, trying to keep as much light in as possible, but at the same time, you are still getting the new frames. And that's just making it look like it's longer. But if you wanted to know the point of where from the LED turned off to the point of where it actually went full black 0 is around 8.8 milliseconds. As you can tell right here, I've measured one just for you. But if you again take a closer look, you can see this is exactly the 2 millisecond mark right here. And this is where it registered. So the official latency of picture to picture or frame to frame or whatever you want to call it is 2 milliseconds. But you also have to factor in whatever the software is doing to keep as much light as possible. All cameras do this, actually. Every single camera does this. They always have that increase of latency. But the theoretical latency is 2 milliseconds, or the realistic latency is 2 milliseconds of when the scene actually changed. But then you have this other stuff kicking in that makes it seem like it's longer. But again, it already picked it up right here that there was the change. So it is 2 milliseconds. So you can take this as 8.8 milliseconds, or you can take it as 2 milliseconds. It's up to you. But either way, this is still below 10 milliseconds. This is just still insane. Even, some racing cameras don't even have 2 milliseconds of static latency. So Foxeer did a really great job. The price is pretty expensive, but I see why. You get amazing low light performance and also insane latency and good image quality. They are pretty big though. They're packing pretty big sensors. But overall, this is just this is really good in my opinion. I'd definitely put this on a build, especially for those summer nights. So yeah, well, that's it, guys. I'll have everything linked down below. Go ahead and check those out. Those greatly support the channel. And also come join my Patreon. I do a ton of giveaways. And even new Patreons get their own separate giveaways. So if I have 2 new Patreons, there'll just be a giveaway between them two. So your probabilities of winning are really, really high. And I try to give back as much as possible. And well, that's it. Everything's linked down below. Go ahead and check them out. And I'll see you guys in the next one. Peace out.